Hi, welcome to our second complex numbers video. We're going to factorise quadratics in this video. Factorising is the opposite process of expanding. It involves putting the expression back into brackets. And we're going to take the expanded form and factorise it back into factored form. All right, example 1. Let's factorise 6x squared plus 21x. To do these quadratics, I like to break them up into 3x times 2x. And 21x can be broken up into 3x times 7. And we can clearly see there's a common factor of 3x, which goes out the front of the brackets. And what's left over for each term? We have 2x left over for the first term. Then we can put our plus sign, and we have 7 left over for our second term. So our final factored form is 3x times 2x plus 7. All right, number 2, let's factorise x squared plus 8x plus 16. These are the more common ways you see quadratics. We're looking for two factors that multiply to get 16 and add to get positive 8. And the two factors are 4 and 4. 4 times 4 is 16, and 4 plus 4 is 8. Now, because they're both the same factor, we could write it as x plus 4 all squared, which we call a perfect square. All right, let's move on to number 3. Let's factorise x squared minus 6x minus 16. Again, we're looking for two factors. They must multiply to get negative 16 and add to get negative 6. Now, the two factors we're looking for are x plus 2 and x minus 8, because 2 times negative 8 is negative 16, and 2 subtract 8 is negative 6. But remember, we can write them with the factors in a different order, so we can write it as x minus 8 first times x plus 2. All right, let's move on to number 4. How do we factorise x squared minus 49? Well, just know that this quadratic can be written as x squared plus 0x minus 49. So again, we're looking for factors that multiply to get negative 49 and add to get 0, and the two factors are plus 7 or minus 7. Number 5 is getting trickier. Let's factorise 4x squared plus 32x plus 48. We notice there's something common between 4, 32 and 48. It's the number 4. So if we divide everything by 4, we're left with 4 out the front and x squared plus 8x plus 12 inside brackets. Now we can look inside the brackets and continue our factorisation. We can find two factors that multiply to get 12 and add to get 8, which happen to be x plus 2 and x plus 6. Again, we could rewrite this as 4 bracket x plus 6 times x plus 2. Now keep in mind, please, that if we want to multiply the 4 into the brackets, we don't multiply them into both brackets. We can only multiply the 4 into one of the brackets, the first bracket or the second bracket. All right. Finishing with our really tricky factorisation problem, and I hope you've practiced this in level 1 and level 2 and got a bit confident with it. Let's factorise 10x squared plus 3x subtract 4. We could sit around and just guess and check and find the one we need, but we're going to show you the formal technique. And here's how we do it. We take the coefficient of x squared, 10, and times it by the constant, negative 4, to get negative 40. Then we list down all the factors of negative 40. We look around for the pair that add up to give the value of b, the plus 3, the coefficient of x, and that happens to be negative 5 and 8. Negative 5 plus 8 is 3. Right, what do we do now? Well, we take our expression 10x squared plus 3x minus 4, and we write it in a different way, 10x squared minus 5x plus 8x minus 4, because minus 5x plus 8x equals 3x. Now we start with the first two terms and we factorise them. What's common? 5x is common, so we take 5x out the front and that leaves us with 2x minus 1. Then we factorise the second part. What's common? 4 is common, positive 4, and that leaves us with 2x minus 1. Now, if both brackets are the same right now, this technique's working well. So our final answer is 5x plus 4 times 2x minus 1. How do we get those two brackets? The first bracket is 5x plus 4, and the second bracket's whatever's inside the brackets. So our final answer could be 5x plus 4 times 2x minus 1, or 2x minus 1 times 5x plus 4. Thanks for watching.